In this video, we are going to talk about the periodic table, which is really kind of like learning the language of chemistry. The periodic table is just an arrangement of all the known chemical elements according to their properties. And they're arranged in such a way that these different properties occur periodically. Haha, yep, that's what happens. And so each of these elements are arranged in such a way so they're around other elements that have similar properties. Now, the first periodic table was created by Dmitri Mendeleev. Dmitri Mendeleev. Now, to be clear, at the time in the 1870s, there were many different forms of the periodic table. But what made Mendeleev's so much better, or the one that was adopted, was that it was organized by increasing mass. So it was organized by increasing atomic mass. And so this was very important because it created gaps. And that way, you could know what you were looking for. And so Mendeleev's periodic table correctly predicted the properties of elements that hadn't been discovered yet. So anytime there was a gap, it was predicted, okay, that's an element we don't know. And we can try and go find it, right? It has to have a certain amount of stuff that makes it up. Now, when you are looking at the periodic table, it is going to be arranged by what are called groups. Groups are the columns, and then we have the rows, and those are the periods. So periods are going to be the rows. There we go. Now we got it right. All right, so you can see that the groups are numbered 1 through 18 across the top, and the periods are numbered 1 through 7 down the side. Now, what's a little bit strange when you first look at the periodic table are these two periods right here. These are not separate periods. That's why they don't have a number right here. If you look at the numbers, right here we have 56, 57, and then it jumps to 72. And that's because the 58 through 71 are down here. So these are classified as the lanthanides. And you can see after actinide, we have this group here. So we have the lanthanides and the actinides. Those are down here. And so a lot of times the first one will be referred to as the lanthanide series, and the second one will be the actinide series. Now, group one is known as the alkali metals. Group 2 is known as the alkaline earth metals. Then we skip all the way over to group 7 or 17. This group here is known as the halogens. And then finally, group 8 or group 18 is known as the noble gases. Those are the noble gases. Now, this big chunk here in the middle in green, these are the transition metals. So this gives you an idea of all the different areas of the periodic table. And when someone says the halogens, they are referring to everything in group 7 or 17. Now, you might be thinking, why are there different numbers? Well, sometimes the periodic table is numbered 1 through 18, as shown here, and sometimes it is labeled as group 1, 2. It skips all of the transition metals, and then group 3 is over with boron. So it can also be numbered like that. When you are looking at the periodic table, the atomic symbols are a unique abbreviation for each element. So if we look at this periodic table here, I can see there are a lot of different letters, and they're all going to represent an element. Now, each symbol is going to be a combination of one or two letters. The first letter is always capitalized, and the second letter is always a lowercase. And it's very important that when you are communicating, you do so correctly. So, for example, cobalt is CO. But if we forget to make that a lowercase o, it changes from cobalt to now carbon monoxide. So these two things have very different physical and chemical properties. So it's very important that you communicate clearly. Now, a lot of these symbols will come from the beginning of the name. So Be is beryllium. Po is polonium. The name of these elements are not capitalized. So you don't have to capitalize the name of elements. They are not proper nouns. Now, other element symbols will come from Latin names. So Au is gold. The Latin name for gold is iron. Fe is iron. The Latin name for iron is ferrum. So that's where these symbols can come from. Now, the simplest way that the periodic table is divided is by whether the element is a metal, nonmetal, or what is called a metalloid. Metalloid is a fun word for me, especially because I like to use my robot voice when I say it. So it is a metalloid. All right, so let's look at the properties of these different substances. Metals are good conductors of heat and electricity. They are solids at room temperature. With the exception of mercury. So, mercury, which is given the symbol Hg, is a metal that is a liquid at room temperature, but that is the only metal that is a liquid at room temperature. They also have high melting points, and a melting point is the temperature at which a solid melts and it will form a liquid. Now, nonmetals are poor conductors, and they're poor conductors of heat and electricity. They can be solids, liquids, or gases at room temperature. And because of that, their melting points are going to vary. Some, they are going to be much lower than that of metals, though. So let's go ahead and add that in. They're going to have lower melting points. Now, a metalloid is going to have properties. So, metalloids have properties between those of metals and nonmetals. So, they can conduct electricity and heat, but they're not good at it, but they're not poor at it. And so, a lot of times they're called the semiconductors. They are solids at room temperature, but they're going to have lower melting points than that of metals.